Okay, welcome to Algebra 2 with Mrs. Chair. Let's take a look at finding the equation of a parabola when we have the focus and the directrix. Of course, the parabola is a quadratic function, and it could look like this. Okay, so this visual kind of provides you with all of the important information and the vocabulary that you need to successfully understand the topic. So first of all, let's just discuss right quick what a parabola is. Okay, a parabola is the set of all points P. Find the 2 points on the parabola as examples. Okay, so again, the parabola is the set of all points P with the coordinates x, y in a plane that are an equal distance from both a fixed point, the focus, and a fixed line, the directrix. A parabola has an axis of symmetry perpendicular to its directrix and the axis of symmetry will pass through its vertex. Passes through the vertex. The vertex of a parabola is the midpoint of the segment connecting the focus and the directrix. Midpoint, halfway. So again, a lot of vocabulary. Just make sure you understand what it just said. So I'm going to have the wording show as well so that you can read it again if you need to. And here's what it really says. The set of all points on the parabola that describes the parabola, obviously, just like with linear functions, all the points in their entirety, so to speak, will represent the graph. So similarly here, you have one point as an example, a second point as an example, and here's what they're doing. They're connecting it to the directrix as well as to the focus, and they're saying that these two segments are congruent. And then they're doing it again from a different point, and they're saying, as I connected to the focus as well as to the directrix, these two are also congruent, and that is always true. Now that is very important because down here, it tells you left side equals right side. Anytime you have an equal sign, you want to consider the left side of the equal sign and the right side and understand that they're balanced. Okay, that understanding will be very important when we calculate the equation of the parabola. So here's your job. Use the distance formula to find the equation of a parabola with focus 0,3 and the directrix y equals -3. Okay, notice that the directrix will always be a line, and there's a horizontal line through -3. All horizontal lines will start with y equals, and they will not show an x because the slope is 0. Okay, so here's the distance formula for you, and let's work it out. So remember, f, the focus, is at 0,3, and the directrix is y equals -3. So let's get it started. So here's what it said, or by definition, right? By definition, PF, which will be from the point to the focus, will be just as long as from the point to the directrix. That's the idea. And if that is true, and we had to use the distance formula, and they kind of gave it away, that you kind of have to know. The distance between 2 points, right? If I can find the distance and I can show that this segment is equal to the other segment, I may get somewhere. So that's exactly my hope. So here's the distance formula. Minus y1 squared. I kind of like setting up the skeleton, and that's what I'm going to do here. So the skeleton shows me there's a plus here. The distance between 2 points, you obviously always subtract here. And then you have a second point as indicated. And don't forget the squared. Okay, so one is a subscript, the other one is an exponent. And then you have the square root thereof. Okay, fine. So what I'm having here is the point, the focus was at 0, 3, and the directrix was at y equals -3. Now here's my problem though. Okay, so while I can sketch it all day long, and I'll say 1, 2, 3, there's my focus, I know that. And then the parabola is not going to go through the focus. We know that. It's going to be equidistant to the directrix. So let's do the directrix right quick, which is this guy, 1, 2, -3. And it's going to go like this. Okay, horizontal line. Boom. That's the directrix. Okay, so now I need to graph the parabola. And, well, I want the equation. Okay, so all I know is it's going to be somehow like, who knows how. Okay, so somehow like this. And I do know that any point here, when connected to F, and when connected to D, will be equidistant. So let's do it. Let's replace our X and Y. We know that the first guy right here will stay in as is. And then I need my values. So 0, 3, that's on my left side. I'm going to use that. And that would be -0 plus y minus 3 squared, square root thereof. Don't forget that. Don't drop the square root. You know, you think you'll remember later, but then you won't. Okay, so now this is here. This is the really weird part, okay? Because, oh, look what I did. I did not really drop it down to the directrix, did I? So let's fix that connection right quick, because I only went to the x-axis instead of all the way to the directrix, which must happen at a 90-degree angle, as we know. Okay, fine. So now they're supposed to be equidistant. Here's my problem, though. I don't know the coordinates of this point on the directrix. So I do know my y value, but I don't know my x value. So I'm going to just plug it in, okay, right here as my x. You may find it a bit odd. Well, just get over it. Plus y. Now, am I putting -3 in? Or am I subtracting -3? Making this a +3. How about that? So that's what I'm going to do. Don't know about you. Now, square root of equals square root of. I'm going to focus on what's happening down there and then get rid of the square root plus. And it's okay to just really do one step at a time so that you don't get confused. Now, what happens when I do 0 to the power of 2? Well, it's gone, isn't it? So now, at the same time, on my next step, I'm going to go ahead and say, well, if I have my square root on both sides, I might as well consider that gone by technically squaring both sides, all right? So that makes the square root disappear. Okay, now I can just write down what's left and decide what to do. X squared. And even if it is repetitive and you're like, yeah, okay, I already know, why don't I take the next step? Because you don't want to lose sight of what's happening. Keep it organized. Speaking of, it's always a good idea to kind of keep your equal signs relatively aligned, just to kind of visually help yourself stay focused. Okay, what's happening? I have a binomial squared, another binomial squared. I cannot work with it without opening it up. Okay, so I want to open it up and see what happens. And you better remember that this is a binomial times itself, okay? Never do this. That is really bad. Don't do it wrong. So instead, write it out. Like I said, nothing wrong with taking an extra step. Y squared minus 3y minus another one. Well, that you could do without writing it out. Plus, but okay, we'll just do all the steps here. Okay, so that's x squared plus y squared minus 6y plus 9 equals y squared plus 6y plus 9. Okay, what's happening? Now, what's my goal? Sometimes it's easy to even forget what you want to do. It's like, where are we going? Well, I'm actually hoping to get y equals, right? So that's what I'm going to do. Get rid of what you can, and then, focus on what is still there. Minus y squared, let's say, on both sides. So that makes this disappear. Y squared is gone. Minus 9, also gone. Okay, so what I have left is this guy and this guy. Okay, so to keep it clear, I'll just go ahead and remove the steps so that you can see my x squared and whatever else is left. So what's left is x squared. The 6y is going to move over and become 12y. Now, obviously, I can write, if I prefer, 12y equals x squared. Symmetric property there. Division by 12 is my last step. Okay? Y equals 1/12 x squared. Da, 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 da. How do you like that? Are you happy now? That's a trick question. Okay, here is the solution for you if you want to see it typed up and summarized for you so that you can see one more time. Okay, so here's your job. In your own words, how do you find the equation of a parabola when given the focus and the directrix? Try that. And once you have it formulated in your mind or on paper, you can try this one. And yes, there is an answer to it all the way at the end. I'm not going to show you. Ding, ding, ding. Okay. I hope it helped. Have fun.